It's a pleasure to have each of you join us from around the globe.
What might not be as well known is that next to our materials, we also support our customers in the application development, from the initial idea to the finished product. And we do this through AM services such as design, simulation services, testing services, and TCO. And this is the department that I'm in. And exactly this application development with our customers is the reason we joined forces together with Hyperganic, because this way we can combine our expertise in materials together with Hyperganic's expertise in software to build a software solution that makes the development of Lattice applications for our customers much easier and more accessible. So I'm very excited to announce today the open beta launch of HyDesign together with Moritz from Hyperganic. Yeah, so for everyone who's not as familiar with lattices, I want to briefly explain what lattices are. Lattices is actually something that you will find everywhere in nature around you. Lattices essentially are structures with repeating patterns of interconnected elements. They provide a structural support to withstand mechanical stress, while at the same time optimizing material usage for lightweight. And these structures derived from nature become increasingly interesting in manufacturing, and with 3D printing, they can be realized quite easily. When you find these lattice structures in football helmets, in bicycle helmets, ice hockey helmets, you find these structures in bike saddles, in footwear applications such as shoes. And here they typically enhance the product performance, they reduce the material usage, and enable innovative designs. Now, as interesting as these lattice applications are, the development of these lattice applications still require a lot of expertise in order to design these complex structures. And oftentimes what we see is that companies that have an idea to replace a certain foam part with a 3D printed lattice structure, during the development, they drift off in what we call the lattice roads to hell. You have to choose and select the right printer, machine, material combination. You have to invest into a software. You have to invest into the license. You have to educate and train your engineers. That can already take several weeks. Up to months. You have to then, once you understand, let's say, the basics, you have to understand what is the right lattice structure, for instance, to mimic the behavior of such a foam. There are so many different lattice types out there that you have millions of options to choose from. The lattice application development should not be this difficult. In order to not make it so difficult for everyone, we decided to do two things. First, we built a lattice library. Is fully publicly available, and it contains all pre-selected validated lattices that allow you to quickly filter what lattices work for what applications. And here you can filter the lattices by applications, for instance, footwear, protection and seating, or you can filter by the technical requirements such as the stiffness, the show hardness, the compression stiffness at certain rates. And this really helps you to find the right lattice much, much quicker without having to go through the lengthy development cycle. Now, the second thing that we did in order to make it easier was to partner up together with Hyperganic. So we listened very carefully to the users of the Lattice Engine and to the overall market, and we incorporated those features and functions into the cloud solution called HyDesign. The Ultrasim Lattice Engine is now maturing into HyDesign as of today.
Such as shelling, booleans, offsets, skinning, transforms, essentially all the functionality one would need to create functioning latticing products. And additionally to that, we introduced a far more capable and far more versatile TPMS approach. Before, you only had the option to do grid-based TPMSs, while now you can do pretty much everything with TPMSs that you would wish for. You can grade them, you can vary cell sizes, you can map them spherically, cylindrically, you can merge TPMSs into each other. So you'll see my browser now. And I'll open up HyDesign, but I'll import now also the midsole file. And now let's infill this with a BAS forward AM lattice. This page that lists all the validated materials that the team at BASF has created for us. So now that I know what lattices to use, let's go back to the product. I select the footwear latticing pad to filter as well. I select the code B and I select 1. And you'll see a uniform lattice infill through this midsole. I'll quickly disable the view of the gluing line, and in fact you'll see the midsole is entirely infilled with one latticing structure. So now I want to modulate my lattice thickness. I can go back and do that by uploading grayscale images. It's same as you're used to it already from the Ultrasim 3D Lattice Engine, a very accessible way of doing so. We can essentially stretch the images so that they fit over our midsole file. And we'll see that in the areas where there's a bright color, in this case white, the lattices will be thickened, while in the areas where it's black, the beam thickness will stay at the minimum value. So therefore, let's increase the maximum stiffness number, essentially the beam thickness, and run this modulation. And in just a second, we should see the results. There we go. So now, as promised, you can see that in the area where we had white color, we see that the lattice beam thickness has been thickened quite a bit. And in the other areas, it remained thin. I'll Boolean union these together into one midsole that we then can export and put on the printer. So the last step remaining is to export this file. We support a wide range of exports. We support STLs, decimated STLs, where you can specify a relative error in order to determine the ultimate file size. The bigger the error, the smaller the file size, obviously. The same holds true for decimated 3MFs, and we support surface 3MFs. Surface 3MF are the essentially OBJ-based 3MF, the traditional 3MF. Shout out to Duan in case you're watching this. We support volumetric 3MF, PNG stacks, CLI files, which are laser path files, and our proprietary HVX file, and select export. So you could infill objects with only one TPMS all the way through, or you can add a pattern like I did here and merge two patterns into each other.
Thank you so much, Moritz and Marius. That was really exciting. We really saw the unique capabilities of HyDesign and how easy it is to create superior lattices in a matter of minutes.
And coming to talking about features, our feature roadmap is packed with very, very exciting new developments. As you all know, Hyperganic develops technology such as simulations as well. And we're looking to integrate our immersed boundary simulation methods, our meshless simulation methods for structures and fluids into HyDesign in the coming months. Also more immediate for the consumer good applications, we'll launch some features to conformal latticing and further extensions to our TPMS capabilities.
And until next time, stay curious, keep innovating, and let's keep moving forward together. Thanks so much.
Thank you, everybody.
Thank you very much.